In this video, you will learn how to find the probabilities of compound events. To begin, let's review how to do probability. In the first example, it says a box contains 6 red markers, 3 green markers, and 4 blue markers. 3 are selected in succession. Find the probability of selecting 3 red markers if, in part A, no replacement occurs, so we pull one out, the next, and then the third, or in B, replacement occurs each time, so we pull a marker out, put it back, pull a marker out, put it back 3 times. So let's start with A, no replacement. Well, again, for probability, if we want to find the probability that we succeed, here succeeding would be getting a red marker. So we need the number of possibilities to get a red marker divided by the total number of markers. Then remember, we're going to have 3 draws. So there's the first time we take a marker out, the second, and the third. The first time, there would be 6 red markers out of a total 6 plus 3 plus 4, which would be 13. The second time, I've already taken 1 red marker. Now there's only 5. And keep in mind, we took away 1 marker from the total, so there's only 12. The third draw, there's only 4 red markers and 11 total. Now because I need each of these events to happen, I want to multiply each fraction. When we multiply, remember you're multiplying the numerator straight across and the denominator straight across, or if you were using your calculator, use parentheses around each fraction. Multiplying straight across, 6 times 5 times 4 is 120, and 13 times 12 times 11 is 1,716. If I can simplify this answer, I would want to. And this is going to simplify to 10 over 143. That is the probability that I would select 3 red markers if we didn't replace. Now in part B, if we do replace, that's going to be a little different. Again, we're going to have 3 draws. And the first time there would be 6 red and 13 total. But the second time there would also be 6 red, 13 total, as would there be the third. Again, I need each event to happen, so I'm going to multiply. And if I multiply this out, I have 216 over 2,197. This does not simplify, so that would be my final answer. Now, in probability, we have events that are disjoint, which is the same thing as mutually exclusive, and we also have overlapping events. Let's first look at the 3 possibilities. So in this first one here, you can see that there's some overlap. Part of the possibilities from event A overlap with part of the possibilities of event B. Here in the second Venn diagram, we were only looking at the intersection of the 2. So you only cared about the times when both events A and B happen. And then lastly, notice there is no intersection of A and B. Those are what we call disjoint events or mutually exclusive. So disjoint events are going to be 2 events that never occur at the same time, as we see in this third Venn diagram. If we want to find the probability of 2 disjoint events, we do just like we did when we had independent events that either one or the other could happen. You took the probability of the first event, probability of A, and added the probability of the second event, probability of B. So basically we're not going to do anything different. So let's take a look now at example 1. So in example 1 it says Gina has 6 pennies, 4 nickels, and 5 dimes in her change purse. She takes 1 coin from the purse at random. What's the probability that it's a nickel or a dime? Well, it's never going to be possible for pennies, nickels, or dimes to be one of the other coins, so that makes them disjoint or independent, mutually exclusive. And so to find the probability of her pulling out a nickel or a dime, you basically just need to find the probability of a nickel, and because again it's or, add that to the probability of a dime. And so the probability that she would pull a nickel, well, since there's 4 nickels, she could have 4 chances out of the 6 plus 4 plus 5, 15 coins of drawing a nickel. Or, addition, there are 5 dimes, and so she has a chance 5 times of pulling a dime from the 15. Now again, these are 2 different events, and so only one of them is going to happen. So there's no worry of making it only out of 14. So now if I add these fractions in the numerator, I just add the numerators. 4 plus 5 is 9. The denominator stays the same because I had a common denominator. And then again, if we can simplify, we always need to simplify to the simplest form. 9 over 15 are both divisible by 3. Please now look at example 2, pause the video, and check your answer when you're done. In example 2, there was 6 people that had high blood pressure out of the total of 50 patients. There was also 10 people that had the other condition. So again, because it's or, if I add these 2 independent events together, 16 out of 50 simplifies to an 8 out of 25. Now let's look at example 3. It says a pair of dice are rolled. What's the probability of rolling a 9 or rolling doubles? When they say rolling a 9, we are referring to rolling something that sums to 9. So let's look at our deck of cards sheet, since there's also dice possibilities on there. Down here at the bottom, we see our dice possibilities. Doubles would be any time that you see 2 of the same dice. So a 1 and a 1, 2 and a 2, 3 and a 3, 4 and 4, 5 and 5, or 6 and 6. As far as dice that sum to 9, well, here 4 and 5 sum to 9, and here's another 4 and 5. 6 and 3 sum to 9, and here's another 6 and 3. So it looks like there's going to be 4 places where we sum to 9, and 6 times when we get doubles. So if we now bring that information back to the problem, the probability that we're going to sum to 9 would be 4 out of the 36 times. Or, so addition, the probability that we would roll doubles would be 6 out of 36 times. Adding those together, 10 out of 36 simplifies to 5 over 18. Now all of these were disjoint events. Let's now look at events that are overlapping. So what are overlapping events? Overlapping events are events that have some outcomes the same. If we look back at our Venn diagram, this first Venn diagram would be an example of overlapping events. The events here in the middle are overlapping. They occur in both event A and event B. Now an example of an overlapping event comes from our deck of cards. If I look at the possibilities, there are times where I could pull a 2 card 4 times, or I could pull a club. If I look at the 2 events, there is actually going to be one place where I would be pulling both a club and a 2. That is the overlapping event. Now, as far as how to figure out an overlapping event, you start out the same. You're taking the probability of A or B. And so you're going to be adding the probability of A plus the probability of B. But if you did that, there would be a time in that last example where we included the 2 of clubs in event A and the 2 of clubs in event B. And there's obviously only one 2 of clubs in each deck of cards. Therefore, we also have to subtract out the probability of drawing both a club and a 2. So the probability of both events happening at the same time. That way they'll only be included once. So let's look at example 4. In example 4, it says a pair of dice is rolled. What's the probability that the sum of the numbers rolled is either an even number or a multiple of 3? Well, let's first think about the sum of dice. So on our dice sheet, we can see that we can get different values. We can add to a value of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. So in the question, we were looking for the probability that we sum to an even number or a multiple of 3. So we would sum to an even number when we sum to 2, 4, 6, 8, 10, or 12. So let's figure out how many times we sum to an even number. If we count it up, we sum to an even number 18 times. So the probability that we would sum to an even number would happen 18 times out of 36. Or, so we're going to add, we need to know the probability that we get a multiple of 3. So again, let's look at the dice sheet. Multiples of 3 are going to be 3, 6, 9, and 12. And so let's look at where that happens. So if I look at the yellow highlights, there are going to be 12 times where I sum to a multiple of 3. Now, if I look back at the dice sheet, there were a couple of times where I was summing to a multiple of 3 and an even number. Whenever I got a value of 6, I was summing to an even number and a multiple of 3. Also, when I summed to 12, I was summing to an even number and a multiple of 3. So that happened 6 times. That means we included those 6 possibilities twice. We only want to include it once. So now we have to subtract out the probability of both. And again, that was 6 times out of the 36. If we now add and subtract the numerators, 18 and 12 is going to be 30, minus 6 gives me 24 out of the 36 possibilities. And simplifying that fraction, I get a 2 out of 3 chance of either summing to an even number or summing to a multiple of 3. Please now pause the video and do example 5. In example 5, we had 15 seniors and 12 said they were going to study for the semester exam, 6 said they would do the review packet, and 8 said they would do both. What's the probability that a senior chosen at random would either study or do the review packet? Well, again, we need the probability of seniors that would study. There was 12 out of the 15. Or, so addition, the probability that they would do the review packet, 6 out of the 15. And then you have to subtract the overlap, the 8 people that said they would do both out of 15. Adding and subtracting the numerators gives you 10 over 15, which simplifies to 2 out of 3. Please now pause the video and do example 6A. Here, we wanted to know the probability of drawing an ace or a king. Well, it's never going to be possible for a card to be an ace and a king, so these events are disjoint. So if I look at my deck of cards sheet, there are 4 possibilities for drawing an ace, and there are 4 possibilities for drawing a king. Again, I have no overlap, no place where I have both an ace and a king. So that makes these disjoint. So since for an ace, I have a probability of 4 out of the total 52, and for a king, a probability of 4 out of the 52. This is why I did 4 over 52 plus 4 over 52. I didn't have any overlap to subtract out, because again, an ace can never be a king at the same time. So 2 out of 13. Please now pause the video and do example B. In example B, this was overlapping. there is one card that is going to be both a king and a spade. And we can see that on our deck of card sheet. Again, as far as kings, these are all my kings. As far as spades, these are all my spades. I can see that there is one card that overlapped, both a king and a spade. So again, that tells me I had overlap. And I need to subtract out the extra event so that I don't include it with the spades and with the kings. So the probability of a king was 4 out of 52. Probability of a spade, there's 13 spades out of 52. Minus the one card that was in both of those events. That was both a king and a spade. So 4 plus 13 minus 1 is 16 out of 52, which simplifies to 4 out of 13. Please now pause the video and complete parts A and B of example 7. The biggest thing to remember in example 7 is that we are selecting 4 marbles without replacing them. So in example A, when we wanted to get 4 blue marbles, when you do the probability the first time of getting a blue marble, that's 5 out of 12, since we had 5 blue marbles and 12 total. The second time, though, now there's only 4 blue marbles over 11 total. The third, there's only 3 over 10. And the fourth, there's only 2 over 9. Now it happens that, if you remember from the last sections, we have 5 blue marbles. We need to choose 4 of them. And here, order matters. Then we have 12 marbles, and we're picking 4 for the total. That calculates out to 1 over 99. In example B, we want to know the probability of white or blue. So there's actually 7 white. We need 4 over the 12 total. Again, we need to choose 4. Plus the blue we just did, and that calculates out to 8 over 99. Let's now look at least 3 white. Remember, at least 3 means that you would have 3 or 4 white. So you have to do situations for both. So let's start with the 3 white. So we need the probability of getting white 3 times and then a not white. Since there are 7 white over 12, the first time we would have 7 out of 12. Then there's 6 out of 11. And then 5 out of 10. Now when we do the non-white, at this point there are 5 blue marbles. So 5 that are not white over, remember, 3 are gone from the total, so 9. This would calculate out to 35 over 396. Or, so we're going to add. We need to have 4 white marbles. For 4 white marbles, we need the probability of getting white each time. So the probability of getting 4 white would look like this, which calculates to 7 over 99. If I add these two values together and simplify, you would get 7 over 44. Please now pause the video and do part D. So in example D, to find exactly 3 white, we would do just as we did in part C and get 35 over 396. But for exactly 3 blue, you need the probability of blue each time and then a not blue. So 5 over 12, 4 over 11, 3 over 10, and then there's 7 that are not blue, but there's only 9 total at the point of drawing the 4th. That calculates to 7 over 198. Adding these two probabilities together, we get our answer of 49 over 396. Please now complete the assignment for day 6.